Today's lesson will focus on an understanding that an algorithm is a solution to a problem expressed as a sequence of defined steps. And eventually in year 13, this will migrate to imperative and declarative programming languages and what's the difference between that. But for now, all we need to do is look at algorithms. You're also going to be looking at what it means to have suitable identifier names. You're going to be able to document a simple algorithm using pseudocode, and then eventually write pseudocode from a structured English description. Now, we haven't covered structured English description in a lot of detail at our GCSE, so this might be the first time that you've encountered it, but it's pretty straightforward. So what do you need to know in Unit 9? Well, let's start by looking at the key terms. You need to be able to define what structured English actually means. So it's a method of showing logical steps in an algorithm using straightforward English words for commands and mathematical operators. So just how we would describe adding things: buy two items, add the price, take away from 100, count the change, whatever. Now, most of the time, you normally will have an algorithm which we define as an ordered set of steps to be followed to complete a task. And these can be represented by a flowchart, which is diagrammatic representation, or pseudocode, which is a set of logical steps using keywords, identifiers, and mathematical operators. So the only difference between structured English and pseudocode is the use of keywords in a way and identifiers, which are closer to programming language. The whole process of designing these is called stepwise refinement, where we divide a large problem into smaller parts until each part is achievable. So let's start by looking at structured English. As the name suggests, it's just normal English language structured in a sequence of steps. So normally we'll end up using line numbers. Think about it more as a recipe rather than pseudocode. So we'll probably say that take 100 grams of flour, that's your step 1. Take 200 milliliters of water, step 2. Add them to a pan, step 3. Step 4 could be mix them together. Step 5 could be start the gas and make sure the temperature is 90 degrees, and so on. So everything is ordered, everything is structured, short statements using mathematical or logic based words, and you will normally use line numbers along with it. So pretty straightforward. In an exam, you might have a series of structured English instructions, which you then will need to convert to pseudocode or vice versa. So nothing very tricky here. Next up is pseudocode. Now, pseudocode gets a bit more closer to programming languages. So we end up using things like command words, print, input, next, for, all of those kind of command words come into play here. There is no need for the programming syntax. So if you think about in Python, there might be a colon at the end. We don't need to kind of put any of those kind of things, but we do need to have something which is exactly like programming code, which is called indentation. That makes the pseudocode much more readable. Another aspect is to make sure that the command words like input, print, for, next, these are in capitals, so they stand out, and that make it easier for perhaps the programmer to code in whatever programming language they choose and directly choose a relevant command word to that capital word. So more on pseudocode a bit later. Let's look at the next thing that was mentioned in the video, flowcharts. Now, flowcharts are pretty straightforward. You probably are familiar with the symbols from IGCSE. They're going to be exactly the same. We normally have things like a start and an end instruction, which is a rounded rectangle perhaps. You normally have a parallelogram for input and output, a rectangle for any kind of processing or calculations, or even things like assignment. And you normally have a diamond, which is for decisions, which normally has two branches, one for yes, one for no. And if you have a loop, chances are a loop will be paired up with a diamond because you've got to make a decision to conduct a loop. And that normally is just a series of arrows pointing back. So if you think about the third flowchart on screen, you will probably see the loop much more easily visible than the other two. The other two are just like snapshots to make it readable for you. So pause the video if you want to have a look at this in a lot more detail. Now let's start by doing a task, because you can't learn pseudocode, you can't learn doing flowcharts or structured English through just listening alone. You need to be able to practice it. So your task is to write an algorithm for drawing a polygon of any size, okay? The size is to be input by the user. And what I want you to do is to first write it in structured English. So make sure you know that you've got line numbers and you've got plain English statements using logical or mathematical operators. That's what you're going to do first. This shouldn't take you more than 5 minutes to do. A pretty simple problem. So let's pause the video and write it down. Okay, so hopefully you've got a structured English set of instructions written up. Feel free to share those with me. But we're going to move on to pseudocode right now, and you will see the link in a moment. But before we move on, make sure you have a copy of this document, which is called the Pseudocode Guide for Teachers. It is linked to the lesson post, so you can download it from there. And just make sure you note the statement in there that says all identifier names have to be meaningful. So we can't just use things like X or I or call variables some random name. Just make sure that they are, even if they're long, they actually represent what you're trying to assign or store in them. So no X, A, B, use things like counter, index, position, and so on, especially when you're creating things like loops. So pause the video again, make sure you download a document and have a look through that. It kind of gives you all the different types of pseudocode that you will need to learn for an exam. Now let's get back to pseudocode basics. Integers is a basic data type used to represent whole numbers. We don't use float in pseudocode. We use real, and this is a number capable of containing a fractional part. Char is the same, a single character. String, we already know, a sequence of 0 or more characters. Boolean, true or false, and date is a valid calendar date. Those are the common data types that you are allowed to use in exams. Okay, so here are some basic ways for you to declare variables or arrays or use them to assign values to any identifier. Declare is used first in capitals, and then you will have whatever the name of the identifier is, in this case a counter, followed by a colon, followed by the type, in this case integer. The next one is again pretty straightforward. Declare total to pay as a real data type. Declare game over as a Boolean data type. When you're declaring arrays, you need to make sure that the array is also declared by using the word declare in pseudocode. Declare pseudonames, colon, and that will be an array. In square brackets, you'll write the length of the array, so in this case 30 characters, and these are going to be of type string. Similarly, you can see notes and crosses. This is an array which is of 2 dimension, so 3 by 3 of char data type. Now if we were assigning values, let's just look back to that variable that we defined earlier called counter. We're just simply going to use an arrow to say that the counter is assigned the value of 0. And we can reassign the value to the counter, especially if you want to increment it. You can increment it in 1s, 2s, 3s, whatever number. And similarly, you can decrement it or reduce it by just simply saying counter is going to be assigned a value of counter -1, -2, and so forth. So they work both ways. And similarly, if you got something like a total, you could do exactly the same thing. You can assign a value to a total to pay variable, in this case, by just simply multiplying the number of hours by the hourly rate. Other common statements are the input and output statements, and these are exactly like those found at IGCSE and previously. Input in capitals, and you can write whatever you want. An answer, output the score, you can output a string, and if you're doing a string, make sure that's in double quotes. You can also have multiple strings, and you can follow them up by just simply putting a comma in there. Other examples, you can pause and have a look at these, are ifs or nested if statements. Again, pretty straightforward. If, then, else, end if. Ifs can be within other ifs, that's why it's called nested. And similarly, you can have formatted case statements, which is the other form of selection, where you simply take an input, and based on that input, you can have lots of different branches of the code. So case will have case of something, and it will have the different branches, and otherwise, which is the equivalent of an else statement, and at the end you need to say end case. Now remember, Python doesn't have a case statement, but other programming languages do. So if you encounter this in the exam, you've got to be aware of that. When you're implementing a case statement, you're probably going to be using an if statement in Python. Next up is how do you assign a group of array elements into an array. So we initialized an array, and that was pretty straightforward. So you've said declare an array. So in this case, let's just say declare student names colon array of 1 to 30 in square brackets of string. So that's the declaration. But we also need to populate it. We need to reserve that space in memory. And to do that, we normally use a for loop. So in this case, we'll say for index, assign the value 1 to 30, student names, bracket index. We just put an empty string in there. And then we just say next index. So it's going to keep looping in, and it'll go to student names 1, empty string, student names 2, empty string, 3, and all the way down to student names 30, empty string. And it just populates that whole array with just an empty string. And you need to do that to reserve space in memory. Otherwise, there is no space in memory for the computer to store anything. Now, how do you assign or access the individual array elements? This is again pretty straightforward. You take the student names, in square brackets, you put the index location where you want to store a new value. And in this case, that value is assigned in a name called Ali. So in student names, the first index, Ali is assigned. And you could also do that for two-dimensional arrays like noughts and crosses. 2, 3 means that in that particular location, store an X if you know your noughts and crosses or tic-tac-toe type games. And you can also use in square brackets increments or counters. So you can do things like n+1, and you can assign values which could be based on changing the position. So if you want to do something like sorting, you could say that the next position holds the greater value, and the previous position can hold the lower value. And so you can play around with that as well. And we'll probably be looking at that in a bit more detail when we start looking at sorting algorithms and searching algorithms and so forth. So just like you have nested if statements, you can also use nested for loops. And in these for loops, you can solve all sorts of problems where you might need to work across multiple dimensions or multiple columns. So in this particular example, what you've got is a series of rows which have numbers, and you want to total each row. So what we're going to do is we're going to start our first loop where we simply say start at the first row, go down to the 8th, 10th, whatever the maximum row is, and then for each row initialize or assign the value of 0 for the total. Once we've done that, we're then going to do another loop and saying for no matter how many columns there are. In this case, we've given it a fixed 10 columns. For each column, just add the value that is in that row's cell to the row total. So row total is equal to row total plus the amount for row and column. So 1, 1, for example. And then it moves to the next column, 1, 2, and then the next one, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, 1, 8, 1, 9, 1, 10. And once it iterates across the 10 columns, it will then output the row total and then add the row total to a global variable which is called total to add all the rows together at the end. And then it will iterate to the second row, and then the third and the fourth, and it'll keep on doing until it reaches max row, which depends on the array that you set up to store all of this. And in the end, it just outputs that global total as well. So not only do you get the individual row totals, but you get a total of all of the row totals as well. Next up, you can use things like repeat until loops. These are pretty straightforward. These are called post condition loops, where you run the code at least once before you check the condition. And similarly, you have a while loop, which is called a precondition loop, where you check the condition first and then you run the code. Now, for loops are often denoted as count control loops because you will have a counter and the loop runs a set number of times. So just be aware of what they are. For is a count controlled example of iteration or loops. Repeat is a post condition. The code runs once and then you check the condition. And while is a precondition loop where the code's condition is checked first before you run any kind of code. And again, depending on the situation, you will need to select one out of the three. And often they might give you a repeat loop and then they ask you to convert it to a for loop or ask you to choose another example. based on whatever scenario they give you. And then the AS level stuff begins with things like procedures and functions and all sorts of things like that. So you should be able to define and use procedures with and without parameters. Now, procedure, when you want to define it, you simply say procedure, name of the procedure. In this case, you can see an example called default square. And to call a procedure, you'll simply use the command word call, and you can say, well, call another procedure called square, and the square's parameter, the value you're going to send to that procedure is 100. End procedure needs to always be used in pseudocode. You can't just start a procedure and not end it, so just be aware of that. You can't start a loop and not end it, so for, end for, repeat until, while, end while, all of those kind of things need to be in place. If, end if, and just like that, procedure, end procedure. And if you look at the examples of pseudocode on screen, you can see how the procedures actually work. So the first one, called default square, is calling a second procedure called square. You jump to the second procedure there, and the size in this case is a parameter of 100, which should be an integer. There's a loop there which says that squares have 4 sides. So for side 1 to 4, call move forward and whatever the size is. Because there's 100 sizes, you call another procedure and then you pass the parameter size, which in this case will be 1. And then you call another one which is called turn, and then you turn 90 degrees, and you kind of repeat that. And that's basically it's really. You've got a basic main part of the code which says if size is equal to default, then call default square, otherwise you call the square of the size, and that allows you to either create a default square of 100 units or whatever the user specifies it to be. And similar to procedures, you've got functions. Functions also use parameters, but they return a value back to the main program, whereas procedures do not return a value back to the main program. That's one difference between procedures and functions. Anyway, so here you've got a function called max, which takes 2 parameters, which are number 1 in integer form and number 2 in integer form, and it will return a value also in integer form back to the main program. Remember, it's very difficult to convert one data type to another, so depending on the data type coming in, the return value is normally the same data type. So in this particular case, you got if number is greater than number 2, then you return number 1, else you return number 2. So it's just a comparative value that's returned to find out what the maximum is out of 2 numbers. And then you simply output whatever was needed. Now, most of the pseudocode that you encounter is going to be pretty straightforward. So you got your operators, you got things like and, you got append, array, boolean. So this pseudocode key is quite useful because in one screen it outlines all the different types of pseudocode that you need to be familiar with. This is at the back of the pseudocode guide anyway, so you can just have a quick look through that. And if there's something that you're not sure of, please do have a look through that. We'll hopefully be practicing most of this as we go through practicing pseudocode throughout the year. But just be aware that you should be familiar with all of these, and you are definitely going to be given inserts related to pseudocode. You're not expected to remember all of them, but there will be the basics that you need to be familiar with, which I've just covered, and the others, they might give you an insert in the exam which you need to follow because it will list the relevant pseudocode which you need to solve a particular problem in the exam. Now let's play around with pseudocode. On screen, you will see a structured English description of an algorithm. You need to convert this into pseudocode based on the pseudocode guide that you got. So you got 3 steps. Step 1, enter time taken to run marathon in hours, minutes, and seconds. Calculate and store the marathon time in seconds, and then output the marathon time in seconds. Okay? So pause the video and then have a go at the pseudocode task. Okay, so do share that with me, because we're now going to move on to the next part. So we're going to extend the original algorithm to this new one. So now you enter the time taken to run marathon in hours, minutes, and seconds. You calculate and store the marathon time in seconds. You output the time, just like the previous algorithm, but then you ask the user for a personal best time in seconds, because they might have run a marathon faster. And if the marathon time in seconds is shorter than the personal best, then you reset the personal best time in seconds to the new one and output the personal best time in either case. So you might have some flexibility in steps 5 and 6 how you want to do those. But what I would like you to do is create a new algorithm which refines your previous one but takes into account the new steps. So pause the video and have a go at this algorithm. Remember, if the marathon time in seconds is shorter than the personal best, then you reset the personal best to the current marathon time because the new marathon time is faster than their personal best. Okay, please do share that with me. And the final task, you might want to write the Python code for this algorithm. And just like I said before, programming and pseudocode and structured English, the more you practice, the better it will be. So whenever you get a piece of program to code or you want to code it, do write the pseudocode beforehand just to get yourself into the habit of writing pseudocode effectively. You should now know the difference between structured English and pseudocode. You should know what flowchart is and the basic symbols, and you should be familiar with the pseudocode guide and what the pseudocode basics are. Hopefully you also practiced writing some pseudocode and some structured English algorithms, and the next stage for us is going to be to build on these and start experimenting with the kind of algorithms that you will need at AS level. That's all for today. Please do remember to share your examples of structured English and pseudocode with me, and I will catch up with you in the next lesson.